get ready to get started. Hello and good morning, and thank you for joining the virtual DevOps panel discussion by Parasoft. My name is Adam Atanasio. I'm a product manager here at Parasoft. Today I have with me a couple folks from our team. We've got Matt Love, who's a senior project engineer at Parasoft, William McCusker, who is a project lead engineer, and Jeffrey Peoples, who is the senior product manager. We all work on the functional products team here over at Parasoft. Got a couple of quick housekeeping items. This is a live session, and we will be answering any questions as they come in. After the session is over, you'll receive a link to view the full session. If you look to the right-hand side of your screen, you'll see a question mark. Please feel free to ask any questions here. Our moderators will be responding directly or pass the question to the panel for a response. At the end of this presentation, we will include a QR code for some additional reading. These can also be downloaded directly using the paperclip icon on the left. So let's bring everybody in here. Morning, gentlemen.
Morning.
So everybody hear me okay?
I'm good.
All right.
I can hear you just fine.
All right. So a few weeks ago, we did a similar discussion with Grigory Trofimov titled From DevOps to DevOps. For those of you watching, you can watch that recording with the QR code at the end. In this discussion, we talked about the definition of DevOps and how you can avoid some of the pitfalls when implementing it. I'd like to expand on that today and discuss how to keep your DevOps workflow running smoothly with simulation. So I guess kind of to get this going, Matt and Bill, kind of have a question to start off with you guys. What role does service virtualization play in DevOps, and how can it be used to kickstart the workflows?
Yeah, so when you think about DevOps, you're running, a number of tests, integration tests, automated tests that you have dependencies on external systems, other services, and part of what causes instabilities and causes failures in those tests is when those services you're depending on aren't in a good state, or are being used by something else at the same time, and data is changing out from under you. So service virtualization lets you get your own, copy of those services without needing, a whole nother live instance. So when I say live instance, you can think of like a credit check service with Experian, right? You don't want to set up another account with Experian. You just want to emulate that service, the requests and responses coming back. So service virtualization lets you capture that, and when you integrate that into your DevOps pipeline,
right,
then you get to really gain control over your integration tests and have them not depending on external changes. So then if anything fails, it's really because the code under test is changing and causing failures. So it's a lot more reliable that way.
All right, and what kind of assets can you virtualize? Like what are some of the common assets that get virtualized in this structure?
Well, typically anything that has communication over the network. So real common examples are, like JSON REST services, but also SOAP XML, and then financial protocols, FIX, ISO 5853, and even database calls can be virtualized as well over the JDBC driver. So select statements and stuff like that to a database can be virtualized. So you don't really need your own live relational database up and running for your integration tests if you virtualize it.
Okay, great. Bill, you got anything to add on that?
Maybe the only other thing to add is I think it comes up a lot in performance environments, right? Where having virtualization could be beneficial to your DevOps because now you can do your performance tests and not have to, similar to as testing in isolation, you can do the same thing for a performance environment where you can isolate it. So now it's just, well, what is the performance of your service that's under test? It's not, well, is there some other downstream service that's acting up and is slow? It gives you a little bit more control over that. Oftentimes the simulation can be faster, right? Because you don't have it. It's not real. It's not touching a database. It's not needing to do all of the necessary business logic and checks and, assuring that everything's correct across the entire system. It just says, oh, you want a response for a message? Here you go. And, that lets you then kind of more easily kind of test the performance of a service that you're not having to have all these back end downstream things that might actually be the source of bottlenecks.
Okay. That's great. And I mean, that kind of brings me to a question on data, since that's come up. Sometimes folks are working with personally identifiable data in their live databases. How can that be addressed with virtualization so that they're not using that real data?
Mm-hmm. So I guess it depends where they get the initial data. So if initially the data they have has personally identifiable stuff, then probably talking more about like things like masking, right? Where you need to go through and be like, hey, let's scrub all this data for me. So don't use the recorded value that I gave you because I know that can't go out. Just mask it for me. The other thing is that, well, when you're using simulation, right, or virtualization, you don't have to use real data, right? You could start from just complete made up stuff, right? You could just generate it, be like, boom, here you go. It was never personally identifiable. This isn't ever going to be a person. This is just, junk we made up, but maybe you don't care, right? Maybe for whatever test you're doing, you just need the virtualization to answer, right? As long as your code can get an answer back, then it doesn't matter if you put in, a social security number that's not real, because what you're testing doesn't care about, is it a real, personally identifiable information? Just, hey, can I send and request that information? Can I get it back? Can I do some things with it? But as to it being legitimate, maybe you don't care. So maybe you just generate it. Maybe you fake it from the start.
Right.
Right? That's what virtualization is here for, right? We fake it, but we fake it well enough that you can get by and do a lot of stuff that you couldn't otherwise do. So,
Gotcha. Jeff, I'm sure you've got some questions too.
Well, yeah. Whenever I think of virtualization for that purpose, I think of the ABCDs, which is A for availability, where you have a situation where you have a asset that isn't available whenever you need it to, just at your beck and call, and so that's an ideal case to be virtualizing. B, as for behavior, you may have an asset, but it's not in the state that you want it, and so you basically can, based on that, virtualize, say, a corner case or an error condition that you wouldn't normally get. And then the C stands for cost, which is kind of self-explanatory, but it basically saying that if everything is related to cost, and so but some assets can be costly to use, and so those you want to virtualize. And then D, of course, is data, and so that's what you already touched on.
Great. So, service definitions can be helpful. How can service definitions be used to help inside of a DevOps environment? And I guess I throw that out to any one of you guys.
Yeah. So they're a really big help when you're starting from, hey, you need to virtualize something, right? Not knowing what messages it sends or what the individual fields or options are can be really difficult, right? You can start from capturing traffic, which is great. You've got all sorts of great heuristics that help you very quickly get up and running. But sometimes, there are little things that without a service definition, you just don't know. You just won't. If something never sends a certain field, you'll just never know it was there. You'll never know that there was an option that, oh, hey, maybe my virtualization, I should, I'd like to have a case where I send that back. Maybe it's incorrect to send it back, and I want to force AUT to deal with that somewhat incorrectly structured data or weird edge cases, as Jeff said. So the service definition can really help with understanding what the full breadth of the service offers. And then it can also help speed up creating the virtualization, because now, as a person, I don't have to necessarily review as much of, the heuristics and kind of making sure, okay, yeah, this does look reasonable and correct. It's like, well, someone has done the work that says this is my service. So when it gets into DevOps and it gets to virtualization, you go, well, this is what you said it does. So now I can just consume that to even more quickly get up and running, and having something that will model what kind of the message structures and what the live service would have been.
Gotcha. And I've heard you guys talk about the dynamic and non-dynamic service definitions in the past. What does that mean to you guys?
Dynamic service definitions. Well, I think a service definition should hopefully be pretty static, right? If you're given a service definition and someone says this is for version 1, ideally, hopefully they're not going to come back, a day later and go, wait, well, here's really version 1. You're like, okay. I mean, maybe that can happen sometimes, right? Services are in development and things are changing, but we would generally kind of hope once something's kind of released that it's somewhat stable in terms of what it describes and what's there. But it's really going to help. The service definition is really going to help because there are pieces in there that, it really makes clear exactly what the service is, what variable inputs it takes and where. It should hopefully, give you a very good contract of like, okay, it should follow this, right? In those cases where it doesn't, maybe that's interesting, but.
Okay.
You're bringing up the word contract. Kind of brings to mind microservices, and what would you say for our audience in terms of applying to be doing this sort of virtualization in DevOps for microservices?
I would say it's probably a great place to do it, right? Because the idea of microservices is that, since they're so much smaller, it should be easier to isolate them, right? It shouldn't need as much. It should hopefully be, like when you've got the big monolith, right? And you're like, I have to start up the monolith, but really all I want to do is test my one service, but I got to get everything up and running. Right? Well, microservice, it's great. You can get your little service up and running, but then it's like, well, what about all the things it depends on, right? It's gonna depend on other things. And so then as virtualization comes in, they're like, well, if you're breaking everything down into little consumable services, then hopefully there are lots of service definitions around there to make your life easier. But if not, it's not a problem, right? But then it's like, okay, well, I start up my little service. Well, it depends on 3 other little services. Well, hey, virtualize those 3 other little services. Now I'm testing in complete isolation. I don't have to worry about, as you said, availability is one of them down. Oh, I can't test because someone else's service is down, right? Now you're just stuck, which is not where you want to be, right? You want to be like, oh, I tested my service in isolation. Everything's looking good. You gave me a service definition for how your service works. I tested it against that. Everything's looking fine. Then integration gets a little interesting if you go and find out like, oh, well, they weren't doing what their service definition said they would do. And then you kind of got a point to go back and say like, hey, this is what you gave us, right? I tested with that. I virtualized with that. And the interactions worked.
So your service definitions in this example act as that contract that you're then trying to test against to be sure that you fulfill all of the requirements.
Right. There's an expectation that as a consumer of that service definition, you're going to adhere to it. If you say you're going to return a field called name, I expect name to be there, right? If it's not, well, wait a minute, you said you would give that field to me. Why isn't it there? So, and again, that again feeds into the virtualization, right? You take those service definitions, you can build much better models, much better assets. And then once your microservice is in isolation, then you can really start testing it and not have to worry about that availability or that, what state others might be in. And you can start pushing and doing different behaviors, right?
Got it. Great. So I'm going to jump off. I noticed the models behind you there. And this is actually going to be a question for Matt, but it's going to kind of reference the models that you have in there. Matt, one of the fun things that's out there, and the reason I reference those models is because it's deploying troops, and then that's going to go through a destruction phase. So I wanted to talk to you a little bit about deploy and destroy, and how that can be used to keep things running smoothly. I want to talk to you a little bit about that.
Sure. So when talking about deploy and destroy, I think it first makes sense to back up and consider virtualized services that are stateful. So that means that across a sequence of calls to a service, it's keeping track and changing state. So that could be anything from depositing money into a virtual bank account to something that has a counter that increments, as more transactions happen. But all those kinds of things, when you have a stateful asset, it makes it hard for that asset to be shared to a wide audience, right? Because one person's using it, or one automated test is using it and assuming, that the state will predictably change. So when you have that, and then you want to scale out your testing, say, your automated test suite runs in several hours, but you have code changes happening every few minutes, and you want to kick off a new batch of automated tests with every code change. They can't share the same test environment because it's stateful. So what you need to do is replicate that virtual test environment over and over again. And so that's the deploy part of deploy and destroy. And it's best if it can be automated so that, when you need to kick off a new run of tests, you deploy up another virtual test environment, reset all the services to their initial state, and then let those tests run against that new deployment. When they're done, you can tear it all down, destroy it, free up the resources. This is a really good thing to be done in the cloud, where you don't have any hardware constraints on how many servers you can utilize for this.
Right.
Like could be in AWS or Azure, and just spin up new VMs to host these virtual services. And during times of peak activity, you can deploy up dozens of virtual test environments, and then when the activity settles, they all get destroyed, and then those resources get released, and you don't continue to be charged for the virtual hardware.
Great. Yeah, and I imagine that cost is a big issue, and why deploy and destroy works
right
in that environment as well. So if you don't have to keep all of the entire environment up the whole time, then that can make a huge difference. I know.
Yeah,
I know this...
and also, I mean, it's better than having build architects set up virtual environments by hand, because then to scale that out, you assign another engineer a task to make a copy of the environment, and then you're paying for human resource costs instead of hardware resource costs.
And that doesn't do with virtualization at all if you have to add a human.
Right.
Great.
And that actually brings up, in my mind, when I think about deploy and destroy, I think about spinning up as many instances as you need for such as performance testing or anything. What would you have to add about performance testing for DevOps?
So performance testing, and there are really two aspects for it. Testing for response time bottlenecks, in which case that's not so much of a deploy and destroy case. It's just that you want to make your external dependencies respond as quickly as possible so that you can measure within your application under test where is it slow on its own. But then also kind of outside of service virtualization, when you're talking about performance testing for throughput and peak transactions per second, then you'll want to deploy up load generators to keep passing more load to your service under test, until you find the point where it can't handle anymore, and that's really good for preparing for really busy times where if you're like an e-commerce retailer, you're getting ready for Black Friday, you'll want to really ramp up your load testing of your e-commerce site and make sure you can handle peak traffic before you announce your new sales.
Got it.
Absolutely. Yeah.
Yeah, you have anything more on that, Jeff?
No, go ahead.
Okay. So how can that help with something like version control, right? So if you've got some minor changes and tweaks that are going, can you use version control to help virtualize things and keep things running smooth?
Yeah, absolutely. So, I mean, version control mostly is where people keep their their source code for the application under test, and certainly as any changes are made, those changes should be tested, and it's good to have version control integrated with your DevOps pipeline, so that the pipeline gets triggered every time there's a new change past version control. It also helps to put the virtual assets that are created that pairs with the application under test also in version control, so that they stay together with the code that they help for testing, and also so that any changes to those virtual assets get tracked, and if somebody changes the behavior on those virtualized services in a way that causes tests to fail, you can go back and track that down to when it happened and revert the change really easily. Whereas if your test infrastructure, your service virtualization infrastructure is not in version control, it makes it a lot harder to roll back anything that was a breaking change.
Got it. Got it.
So your recommendation for, say, a best practice would be to establish like a Git server alongside that all the teams could store their test assets and even their service definitions in.
Yeah.
Okay.
For sure. I mean, and with service definitions, then going back to the earlier topic of dynamic service definitions. I mean, most service definitions will continue to evolve over time, and if you have them saved in a version control system like Git, you can really nicely see what has changed in my service definition and when did it change, and be able to look back and then deduce, okay, is this a change that could be a breaking change that would affect clients of this service, or or it's a safe change, and and do we need to take any actions for it? Do we need to go update some of our test infrastructure because of this change? Whereas if the service definition isn't in version control at all, sometimes those changes fly under the radar and you aren't even aware that they're happening.
Gotcha. So you can definitely take advantages of Git repositories and things like that. How are things like Docker and Kubernetes used? Either one of you want to take that one on? Docker and Kubernetes?
Yeah, I mean, it kind of goes into what Matt was saying, right, about deploy and destroy. Right? They make it a lot easier, right? Especially with cloud providers now being like, hey, we'll give you Kubernetes clusters, or we'll give you servers that are running Docker swarms. So you're like, almost as soon as you've got a container, it's really easy to scale. Like, well, how many of these do I want to run? And then it's just a little piece of like, okay, well, now I need to get, my virtual assets and my stuff in there. But, it makes it really easy to kind of scale up and say like, hey, I need 5 virtual servers because I'm doing performance testing and I want to add more load to my service because last time it was fine with 4. And you can do those kinds of really cool things with Kubernetes, right? Just some of their deployment models, it's literally a number. You just say, I want, you can change 4 to 5 and say go, and it's like, all right, where's the hardware? I don't know. It's not my problem. It just scales.
Sure.
So it does go to that. It also, it's kind of cool with Docker and Kubernetes how it's kind of making install processes easier for some things.
Okay.
Where it used to be like, okay, well, go download something. Okay, run an installer, set up a service. Go configure. A lot of time now, it's like you just Docker run, and it pulls down the whole image of whatever the software or the server, and it starts it up, and you say what port you want to open, and you're kind of going at that point. There's a lot less of the kind of initial setup, so it kind of streamlines that, which is kind of nice.
Cool. That seems like it makes things a lot easier. I've spent many days configuring a machine to set up and run a test environment, and then had to make a minor change in that test environment and start all over again. And so I can definitely see where that's that's definitely a benefit. And just
and
putting
if you do it in the cloud, then you don't need the hardware, right? You just spin up whatever you need. Yeah.
Right. Or I spin up too much, and then my machine just crawls to nothing and can't move anymore, and sometimes can't even shut the machine down because too much stuff is running. So yeah, I can definitely see where that's a benefit. So I mean, obviously we've talked about a lot of different things today, and a lot of different topics. And I know that I'm sure there's some folks out in the audience who have a couple questions. So feel free to send those in the questions section, and we'll get to answering those. So say I'm just getting started, and I'm looking at my traffic files, and I don't know what the first step I would take, what I would want to look at virtualizing first. So how do I go from that first bit of traffic maybe that I've recorded, and start to find the path that I want to take to virtualize? What steps would you look at first, or what's the first service you'd look to virtualize?
Probably the first service I would try and virtualize is something that's got as little state as possible. Just go for like the easy thing, right? I like starting off with a success. So picking something easy that I can, looks like is doable, probably where I would start. I'm kind of like, okay, there's a lot of really powerful things we talked about, right? Deploy and destroy, data masking, right? There's all sorts of things about learning modes and parameterization and complex. It's a lot, right? If you're just getting started looking at virtualization. So probably the first place that I would say start something simple. Start something like it gets a request and it sends a response, and just get that simple, easy thing working, so that start building the understanding of how virtualization is going to work, how virtualization integrates in your environment, and start kind of building from there. So once you kind of got the easy things, then you'll probably have developed some skills, some knowledge about, okay, well, this is how these things work. And then when you go to the next problem, the next challenge, it'll be, you won't have to be starting from zero. You'll have kind of some background of like, okay, well, these are the things I know how to do. These, okay, well, this problem is now challenging me. Maybe there's a new technique I can use that applies it, but it's not going from zero. Like, well, how do I even get virtualization into my DevOps? How do I make my system connect to it? How do I even get a response for a request? You've kind of done some of that on the easy stuff. And so kind of doing it that way. And, there are lots of things in our product that'll, help out with that of like, okay, you just want to do the easy thing first here. We can help you with that. We can get you going pretty quick. And then, yeah, some of the other moving parts, right? Adding in can come later, right? It's like deploy and destroy is pretty cool, but if you do that from ground zero, you might be setting yourself up for a big headache.
I'm sure there's a learning curve there that that definitely needs to be addressed.
Right.
How about you, Matt? Where would you start? Are you on the same page as Bill on that?
Yeah, I think when creating assets from traffic, it helps to start with something you understand. Probably probably the best way is to see what the Parasoft tools would do in terms of parameterization with that data, and check, does it use the heuristics in the tool to identify which parts of your data are dynamic and likely to change in future requests that that necessarily weren't in the traffic you recorded, and see, okay, is this parameterized? Is this going to be handled correctly? Or look at something that was statically mapped in the generated service and see, okay, this thing, it just has one fixed value in my virtual asset, but this is something I can see changing in the future. So maybe I didn't give it enough traffic when creating the asset in the first place.
Gotcha. Now you both did actually mention products. I'm going to pull up a slide here real quick that just kind of has an overview of where our products fit within the manual testing pyramid, and how to start moving, shifting left and kind of moving down the pyramid and getting down to code analysis. And most of the things we've been talking about today sit here in the automated test and the API testing. And with products like Selenic and SOATest, and obviously we've got our Parasoft recorder that make it easy to transition, take that recording file and kind of move it through the whole process. And I know, Jeff, you have a statement that you make about how many tests, how many different types of tests you can create from that one recording. Want to talk about that for a sec?
Well, one of the things I wanted to ask Matt, just before we get off of that topic, and then we'll come back to that. When you mentioned the tools that can define the parameterization, can you share with our audience what those tools are?
Right. So when you have a recording of traffic, you would use virtualize to create a virtual asset from it. The parameterized data itself would go in our data repository, which isn't on the slide here, but it kind of supports both virtualize and SOATest. And at the same time, you can take a traffic file and create the front end of it as an API test in SOATest, where then it will play back that traffic to send requests to some service that you might want to be testing. So you can either use it to use the traffic to create an emulation of the service, or to create tests for the service.
Okay, and the one that then now that's where I thought you were going with it, and to now answer Adam's question. And then I would add, of course, that you also have the ability to create performance tests in load tests using that same asset that you created for SOATest. And so you can turn they're completely compatible. So that also gives you load testability that you don't necessarily have with some of our competitors.
Yeah. So that's another product that is missing on this slide. But yeah, any API test that you create with SOATest, you can then scale it out in load test and run it under some parameter of virtual users. What we like to scale up the virtual users, on a linear scale, starting at 1 up to 100, 1,000, and see how many concurrent transactions can the service under test handle before it starts failing.
Gotcha. All right. So I do have a question here that kind of relates to some of this and some of the things you've just been talking about. It says, can you go over the data repository and how does that interact with PVA? And then it's actually 3 questions. And can you run an external Mongo instance instead of packaged Parasoft one? So let's start with just a kind of brief overview of the data repository.
Okay. All right. So the data repository is kind of a way of, when you're recording traffic, often, and especially you've seen a service definition, you'll usually get different data for different requests. So it'll all be a similar shape, right? It'll all fit to a service definition's response. But then that one particular definition of the response, well, you may have very different instances of it, right? Some data may have three of an item, some may have 4, right? You start getting different values. So it's all very different. And the data repository just kind of helps the virtual asset collapse all that down where you're like, okay, I've got one responder that kind of encapsulates the notion of this particular part of the service definition. Here's the message type, the rough structure and schema for that response. But then all the variations of the data go into the data repository. So when you're dealing with the virtual asset, you're looking at the overall view of it. And when you want to deal with the particulars of the data, well, it's in the data repository. So if I wanted to, on some response for someone named John change their address, I could deal with the data as just data and abstract it out of the virtual asset, right? So that's kind of what it does.
And a bit of how it interacts with the PVA.
The PVA connects to it, right? The PVA knows, all right, this data goes here with this response, and when requests come in, it'll find the appropriate data, build up the right response, and send it out. It all looks like it's one basic. It looks like you configure kind of one thing from the PVA, but that one thing you configure has a lot of power in what it can respond with because all the data is kind of pulled out of that one place and put into the data repository.
Gotcha.
I also did a presentation, a webinar for Bright Talk, where I was showing some of the whiz bangs that it might have been me and Matt actually. Now that I think about it, the whiz bangs of the data repository, and one of those things that I so love is the ability that you can actually have formulas as data, and then so you like, for example, in the loan for Parabank, you can say, instead of having a data point for each of the possibilities, you can say anything less than 100 will pass. And I think that's just incredibly impressive. Whenever I first saw that, I was like, oh yeah, that's great.
So it's always fun when we can get us nerdy types to be like, yes, that's cool,
yeah, totally
over math. All right. And can you run external Mongo instance instead of the packaged Parasoft one? And I know we've been doing a lot of things around Mongo. I know we're just we've got a CRUD tool coming out for Mongo as well. So I'll hand that one off to either one of you.
The short answer is yes. All right, we've been working on kind of making it so that you can set up an external one, and then the data repository connections inside of Soatest and Virtualize can now it'll go and connect to it and it'll use it. So
is that an undocumented feature, Bill, or is that?
That's relatively new. I forget if it was the last release or 2 releases ago, but I remember it was relatively recent that we did something where we said, okay, let's kind of make sure we're on the latest drivers and we can connect to the latest versions and kind of open it up and say, okay, well, if someone really wants to, they've got their own MongoDB server that they can set up. Sure, we can use it. Probably don't want to mix Virtualize using it with other things because Virtualize kind of expects that we can let users just wholesale delete stuff. So don't mix your production servers with your virtualization servers. So if you want to use it for Virtualize, go ahead, but kind of let Virtualize take over the server, sort of.
Yeah, that makes sense. I believe that was released in 2022.1, which is our last major releases when we added the Mongo stuff. So Well, all right, guys. We are right at about time. We do have just a little bit of time here. I want to go over the last few bits. Just some information where people can reach us. So you can always join our forums on Parasoft. We interact with our forums quite a bit. We're just starting to get those built up, but we get a lot of information here and a lot of ideas of new features and new things our folks would like to see in our products. So feel free to hit the QR code here, head out to our forums and add some information, ask questions out there. And then, as I said in the beginning, there are some assets that you can go and download by either using the QR codes that are here or in the paperclip icon on the left. You can see the DevOps, the DevOps replay, as I talked about earlier, how to choose the right service virtualization. And obviously, if you want to talk to someone on our team, you can click the QR code on top there and talk to one of our team about that. Guys, thank you so much for your time today. It was very, very informative. I'm always learning new stuff, diving deeper into the product ecosystem that we've put together here at Parasoft. I'm the new guy out of all of us, so I think I'm the one that benefits the most a lot of times from these types of talks. And beyond that, thank you everybody for your time today, and have a great one.
Okay, thank you.
Great. Thanks, everybody.
Thank you.